A variation on our growth rate function is for compound interest. And you might ask, what is compound interest? Well, if we put money in an investment and it's earning a rate of return, it's usually expressed as an annual rate, we can have that interest compounded. And what that would mean is, and let's say the example we're going to look at is compound monthly, that every month they're going to take 1/12 of that annual rate and add it to the account. In other words, you go ahead and earn that interest for that month. It's added to the amount that you had in there originally, and then the next month you have 1/12 again of just slightly a larger amount. Now you can have compound monthly, you can have compound quarterly. That means that would happen 4 times a year. Compound semi-annually happens twice a year. You can even have compound daily, which is 365 days a year. And there's actually a method by which you can have continuously compound interest. And I think that's going to go a little bit out of the scope of what we're going to study here in this Algebra 1 course, but definitely comes up in some later courses. So let's first look here at the variation of this growth rate function. So our equation is A equals P times 1 plus R over N raised to the power of N times T. And let's go over what each of these variables mean. Well, A is the current amount. In other words, this is the amount after the interest. P is the original principal or the initial investment. R is our annual interest rate expressed as a decimal, not as a percentage, expressed as a decimal. N is the number of compounding periods, and T is the time in years. So you can see from this formula, if we're trying to find the current amount of an investment that had an original amount, an initial investment of P, we take 1 plus the rate in decimal divided by the compounding periods. If it's monthly, that would be 12. If it's quarterly, it would be 4. If it's daily, it'd be 365. And then raise that to the power of N, the number of compounding periods, times time in years. So there's our formula. A equals P times 1 plus R over N raised to the power of NT. Now let's look here at a specific problem. All right, so it says determine the amount of an investment. So we're trying to find A. If $300, that's P, is invested at an interest rate of 3.5%, that rate would be 0.035, compounded monthly. Our compounding periods are 12 for 22 years. So N is 12 and 22 years, 22 is T. So let's take this information and let's plug it into our formula. So we're trying to find, here's our formula again. We got A equals P. A is what we're trying to find. P we're going to substitute in 300 times 1 plus R, that would be 0.035, over N. Our compounding periods are 12 because it's compounded monthly. There's 12 months in a year. Raised to the power of N, which again is 12, times T, which in this case is 22 years. So here we have it filled out. We got A equals 300 times 1 plus 0.035 divided by 12 raised to the power of 12 times 22. And we just plug all that information in, and we're going to find that after 22 years and earning an interest rate of 3.5% that is compounded monthly, that $300 is now going to become $674.20. I love compound interest. How about that?